Assuming you follow our channel or stargazing advancements consistently, you probably already know that the new James Webb Space Telescope is going to totally reform our perspective on the universe. In September of last year, NASA released another picture of the new super telescope that caused quite a stir. The picture shows the icy planet Neptune, and it's the best we've seen of this captivating planet in 30 years. In fact, Neptune is one of the least investigated and, thus, most mysterious planets in the solar system. Before we continue on to the blue ice giant, we'd like to welcome you to subscribe to our channel if you haven't already done so, and activate the notification bell so that you're guaranteed to not miss any of our future videos. Also, give us a like at the end of the video if you enjoyed the latest discoveries about Neptune. Let's start now with a couple of facts about the blue planet at the edge of the solar system. Neptune facts. Neptune is the 8th known planet in the local solar system as seen from the Sun. Furthermore, since Pluto was deprived of its planetary status in 2006, it is now the last. Estimated by width, Neptune is the 4th largest, the 3rd most massive, and the densest planet in the solar system. It has more than 3 times the mass of Earth and is slightly larger than its almost indistinguishable twin sibling, Uranus. Neptune is made primarily of gases, fluids, and ice. Officially, it's an ice giant. For one complete orbit around the Sun, Neptune needs a distance of 2.8 billion miles, an incredible 164.8 Earth years. Neptune was the first planet to be found by mathematical calculations alone. Galileo Galilei had already noted the blue feature in the 17th century, but he confused Neptune with a star. Not until 1846 did the English mathematician and astronomer John Couch Adams reveal through mathematical computation that there should be another planet beyond Uranus, discovered in 1781. Adams' calculations were confirmed around the same time by French astronomer Urbain Le Verrier. The planet was first seen by German astronomer Johann Gottfried Galle on September 23, 1846, gazing at the night sky from the Berlin Observatory, where he identified Neptune as the 8th planet in the local solar system. The trademark of Neptune is its blue color, which is due to the unique vibrational pattern of the atomic structure in gaseous methane, which makes up the majority of Neptune's composition. The pale blue tone also earned the planet the name of the god of the sea, Neptune. Neptune is one of the most underexplored planets to date. Observations of the planet's atmosphere over the last few decades have revealed occasionally dramatic changes in the structure of the ice giant, which has caused great concern among scientists. With so little known about Neptune, experts didn't know how to deal with these observations. James Webb's picture of Neptune. The first exciting pictures of Neptune were provided by the Voyager spacecraft in 1989, launched in 1977. The spacecraft reached the planet after a 12-year journey. However, Neptune was not Voyager's primary goal. The Voyager probes had been designed to fly through the entire local solar system and then enter interstellar space. This picture would remain the best humanity had of Neptune for over 30 years. The Hubble Space Telescope also provided pictures of the ice giant, but the quality was rather unimpressive. Scientists were even more excited for the launch of the new James Webb Space Telescope. In September 2022, we saw Neptune in a completely new way. Not only did Webb capture the clearest view of this distant planet's rings in over 30 years, but its cameras also showed the ice giant in an entirely new light. The image was taken with the near-infrared camera, NIR-CAM, which captures objects in the near-infrared range of 0.6 to 5 microns. As a result, Neptune doesn't appear blue but very dark. The dark areas are likely methane gas, which strongly absorbs red and infrared light. The bright stripes and spots, on the other hand, are clouds of methane ice, which appear nearly white due to the reflection of sunlight. Thanks to this technique, Neptune's ring system became clearly visible for the first time. The rings have long been known to scientists, but previous observations barely allowed for any clear imaging. The rings are thought to be made of ice crystals. The thin bright line circling the planet's equator suggests atmospheric flows. In plain language, these are violent winds and storms raging on Neptune's surface. A newly known vortex at the South Pole is clearly visible in the James Webb image. Also a first is the depiction of the constant band of clouds that surrounds the planet at higher latitudes. Light filtering techniques allow scientists on Earth to determine the exact composition of gases and other structures from a distance. Studying the rings alone, first seen by Voyager 2 in 1989, will provide exciting new insights into the ice giant at the end of the solar system. For astronomers, this is a milestone in the exploration of Neptune and the long-awaited breakthrough for NASA after its lack of funding for its own Neptune mission. For now, the Great Dark Spot, the cycles on Neptune's surface, remain among the last great mysteries of the solar system. In 1989, Voyager 2 discovered the so-called Great Dark Spot during its flyby of Neptune's southern hemisphere. This is a massive storm, similar to Jupiter's Great Red Spot. In 1994, a team of scientists using the Hubble Space Telescope embarked on a mission to study the Great Dark Spot in more detail. To their surprise, the high-pressure region, the size of Eurasia, had suddenly disappeared altogether. The researchers found another dark spot in the northern hemisphere. The fact that this also vanished after just a few years indicated that the massive storms dominating Neptune's surface are far more fleeting than those on Jupiter. On Neptune's surface, the storm known as the Great Red Spot has been raging for centuries, in the same location. Neptune's storms may be shorter-lived than those on its older sibling Jupiter. However, as far as wind speeds go, Neptune is the undisputed king in the system. Its storms reach incredible speeds of 1,350 miles per hour. In comparison, the most violent hurricanes on Earth reach speeds of only 186 miles per hour, so you definitely wouldn't want to experience a Neptune storm. Unexplained cycles on Neptune's surface. In 2020, researchers were thrown into unrest. A group of scientists from the University of California, Berkeley, used the Hubble telescope to observe a storm on the surface that was wider than Earth's Atlantic Ocean. The storm started in the northern hemisphere of the planet. Since the discovery in 2018, Berkeley scientists had been observing the situation annually. In 2019, the storm began drifting southward toward Neptune's equator, where storms usually dissipate. However, to researchers' surprise, Hubble found in August 2020 that the vortex had changed course once again and was heading north. Although Hubble has tracked similar dark spots for nearly 30 years, this atmospheric behavior was completely new. Scientists don't yet know what these movements mean or whether the events are rare or troubling inconsistencies. The largest storm Hubble has ever observed on Neptune was 4,600 miles in diameter. Scientists have been tracking the behavior of the storm since 1993, and they noticed that the storm seemed to disappear at times, perhaps briefly dissipating only to return not far from where it vanished. Researchers are eager to learn more about these events. One theory suggests that the storms vanish temporarily but continue to rage in the deeper layers of Neptune. At times, these events could become visible again on the surface. We don't yet know what exactly is happening in Neptune's deeper layers. NASA would need to send a probe to the blue planet, similar to Cassini. This could be deployed over the planet at the end of its operational time. During its journey through Neptune's layers, scientists could finally gain the data they've been yearning for. This is still a pie-in-the-sky idea, but it's certain that Neptune will get its own probe someday. Perhaps NASA will combine a mission to Neptune with the search for the mysterious planet X, which is thought to orbit the Sun behind Neptune. Since Pluto is no longer considered a planet, Neptune is the eighth and last of the major planets in the system. However, orbital computations of several other objects in the solar system have provided numerous clues that there may be another large planet behind Neptune. Planet 9, or Planet X, could be orbiting the Sun in a highly unusual orbit, so far out that it has not yet become visible due to poor lighting conditions. If Planet X orbits so far out, its orbital period around the Sun could be as long as 1,000 years. Hypothetically, this planet would only become visible to modern telescopes every few hundred years. Neptune's largest moon, Triton. We'll wrap up by taking another look at James Webb's brand new picture. No doubt, when you saw the photograph, you immediately wondered what that beautiful blue glow in the background of Neptune was. Well, although this nebulous vision looks like a brilliantly shining star, the mysterious green shimmer is just a moon. This picture shows 7 of Neptune's 14 known moons, and the one shining so brightly is Triton. It's the largest of Neptune's moons and about the size of Earth's moon. Because this moon orbits its planet in an incredibly circular orbit, scientists speculate that Triton might have once been a Kuiper object captured by Neptune's gravity. The moon appears greenish in this picture due to the special color separation of the image. As a frigid moon, Triton also perfectly reflects the thin sunlight on Triton, much like Jupiter's moon Europa. What's more, Saturn's moon Enceladus ice volcanism has been seen. There is presumably even a fluid sea underneath the moon's ice covering, so a Neptune test would really have a great deal to investigate in this piece of the nearby planet group. Until that opportunity arrives, we stay inquisitive about what novel perceptions the James Webb Telescope will amaze us with. It's sure that scientists will now consistently take a look at Neptune with the new telescope. You have never seen Neptune like this before. The James Webb Space Telescope outshone itself again in September 2022 by catching a shocking picture of Neptune and its rings. This picture gives the most clear perspective on the rings of the far-off planet that we have at any point had. For sure, the fine residue rings are not apparent to the unaided eye. They sparkled very somewhat in a picture taken by NASA's Explorer 2 space apparatus in 1989. However, the quality of the picture was scarcely enough to draw more exact decisions about the ring's composition. What's more, in the Webb Telescope picture, we can clearly witness even the fainter dust rings of Neptune. This picture was made conceivable by the near-infrared camera, or NIR-CAM for short, which can picture objects in the near-infrared range from 0.6 to 5 microns. Because of light sifting, Neptune doesn't seem blue to the Webb telescope but sparkles brightly. The picture continues to show 7 of Neptune's 14 known moons, including Triton. Neptune's huge and strange moon overwhelms this picture as an extremely bright mark of light. Triton reflects an average of 70% of the daylight that hits it, far surpassing Neptune. This picture is interesting not simply because of its surprising perspective and its great composition. Scientists have gained totally new insights into the elements and composition of the planet and its moons nearly at the edge of our solar system. Up to Neptune, the official major planets of the solar system are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Until 2006, we had another planet, Pluto. But since the discovery of more Pluto-like objects in the edges of the nearby planet group, these mini-planets have been downgraded to purported trans-Neptunian objects. The size jump from Neptune to Pluto is, indeed, colossal. Pluto isn't even a portion of the size of its neighbor. Due to its distance, Neptune is the least concentrated on planet in the whole solar system. For quite a while, specialists moreover felt that Neptune was not especially invigorating because scarcely any life was thought to exist in this murkiness, and the ice planet was viewed as infertile and forsaken. However, this was a misstep. As per the most up-to-date discoveries, one of the coldest planets in the system could support an expanse of heated water, and in this, even living things would be possible. Neptune is an ice giant, multiple times the size of Earth. It has a radius of around 15,300 miles and a volume of 15 trillion cubic miles, giving it a primary concern volume multiple times bigger than Earth. Neptune's main constituents are water, methane, and ammonia. Like the other ice and gas giants in our system, Neptune has no solid surface. Its climate extends deep into the planet to the mantle, which comprises of methane and ammonia ice, and that's with a rough core. Researchers believe the ice giant may have an interior warm, even hot, sea, more alive than believed. Neptune's mystery is that it is in no way, shape, or form as dull as analysts long thought. Researchers became aware of Neptune when they found that it has a functioning environment and probably the most rough and strong tempests in the solar system. The climatic peculiarities on Neptune are significantly more like a curiously large rough planet than a gas planet. Measurements have uncovered that Neptune's solid core might be larger and more complicated than long suspected. In fact, extreme geographical cycles inside the planet can make sense of the climate peculiarities. But not just that. Model computations have demonstrated that Neptune could house a warm sea underneath its ice. Sunlight takes an entire 4 hours to reach Neptune's surface. Neptune's normal atmospheric temperature is minus 182 degrees Celsius, making it one of the coldest objects in the planetary system. Between the years 2003 to 2018, the planet experienced huge cooling, and at the same time, temperatures at the South Pole rose. In 2018, scientists saw a fascinating change in the chemical composition of Neptune's air. In this specific circumstance, these very changes gave proof of internal warming, likely caused by gravitational pressure or gravitational interaction between Neptune and its moon, Triton. This naturally raises the question of whether life could exist on Neptune. For quite a while, specialists felt that this was impractical, but this view is slowly changing. Since we have tracked down life in the most unimaginable places on Earth, we need to open our minds to the possibility that life may exist in places in the nearby planet group that we have recently ignored for a long time. We searched on Mars, and even Venus will soon be inspected more closely for hints of organisms in the air. But Neptune was not on anyone's radar during this search. Some extremely courageous scientists even propose that a portion of the unusual spots on Neptune may be caused by multitudes of microbes under the thick ice. This hypothesis currently has few supporters, but who knows, we might be in for a surprise. Neptune's troubled past is another explanation for the huge internal energy inside Neptune. It might have been a collision with a large object. Since Neptune is the only planet that emanates almost multiple times as much energy as it gets from the Sun, some yet-to-be-identified mechanism must be working. Another hint is the strange 28 degrees tilt of the planet's axis. The axial tilt is similar to Earth's and explains why Neptune experiences seasons, unlike on Earth. A season on Neptune lasts not just a few months, but an entire 40 years because of Neptune's significant distance from the Sun. The clocks run a bit slower here. Not only are the seasons a bit longer than on Earth, but also a Neptune year is a bit longer at 165 Earth years. However, since Neptune rotates rapidly around its own axis, a day on Neptune lasts only 16 hours. The planet's quick spin produces some of the strongest winds in the solar system. Neptune is the windiest planet in the system, and winds reach speeds of up to 1,900 kilometers per hour. This makes Neptune's storms even stronger than those on Jupiter. Similar to Jupiter, Neptune also has an enormous storm that forms a prominent surface feature. The Earth-sized twister was first found by the Voyager 2 spacecraft in 1989. In 1994, the storm had vanished from another picture taken by the Hubble telescope. Instead, a little new spot had appeared in the northern hemisphere. In contrast to the 300-year-old twister on Jupiter, the fierce storms on Neptune exist only for 2 to a few years. Since Neptune has specific similarities with Jupiter, it has a kind of combination of a rough planet and a gas planet inside. Scientists thought of an intriguing idea. Neptune seems somewhat out of place at its position on the outer edge of the nearby planet group. Based on the developmental history of the planets, Neptune might have once formed between Mars and Jupiter. It's very possible that some planets in our solar system have traded places over time. Consequently, Neptune might have been pushed to the edge of the system by the gigantic gravitational forces of Jupiter. Another wild theory says that Neptune is so different from any other planets because it didn't initially come from our solar system at all but was caught as a rogue planet by our Sun at some point. If this theory is right, Neptune would be an alien world that semi-bamboozled itself into our solar system. Why is Neptune so blue? Neptune's atmosphere is 80% hydrogen, 19% helium, with the rest being other gases, including some methane. In fact, it is this small amount of methane that colors the planet dark blue. Methane atoms absorb solar radiation in the shortwave area and reflect the blue color. Uranus has a similar distribution of gases, but in contrast to Neptune, its tone is light blue. Scientists from Oxford University tried to unravel this secret in their proposal. They suggested that this difference in color could be due to the density of the methane cloud. The two planets have several layers inside their atmospheres, formed from fine vapor sprays. The base layer is a blend of hydrogen disulfide ice. The second layer is probably exactly what turns the two planets blue. Since Neptune's atmosphere is much more dynamic than Uranus, its second spray layer is thinner. Because of this, more light is reflected, giving the striking blue tone. The third atmospheric layer comprises of large particles of methane ice. The retrograde moon Triton, in the case of James Webb's new picture, will help researchers unlock the secrets of Neptune's biggest moon. Triton is a very dynamic moon. Its surface is covered in methane and nitrogen ice. Methane chips appear, and Triton has extremely dynamic volcanoes. Specialists have not been able to make sense of how the internal heat and the unusual volcanism came about. It was imagined that the seventh largest moon in the solar system is warmed by Neptune's gravity. The volcanoes produce a combination of cold residue and gas into the thin atmosphere. It is possible that these emissions are involved in the development of Neptune's fine rings of residue and gas. A very similar process has been observed nearby Saturn. There, the cold moon Enceladus feeds one of the gas giant's outer rings with small ice particles. Triton is unique among the moons of the solar system because it orbits retrograde around its planet. This suggests that it might have once been a free object captured by Neptune. The strange retrograde orbit and its intense reflection have led to speculation that this moon was originally a Kuiper object. Gravitationally limited by Neptune, specialists now trust the new picture, and considerably more data will finally explain where Neptune truly came from, and when and how Triton became bound to it. Neptune, with a natural breadth of around 30,000 miles, ranks fourth in the list of the largest planets in our nearby planetary system. With its impressive aspects, the celestial body dominates our blue home planet by around fourfold in contrast to Earth. However, Neptune's structure isn't comprised of solid substances but of volatile chemical compounds. Specifically, the upper air layers comprise of hydrogen, helium, methane, and ethane. Along with Uranus, Neptune is one of the ice giants in our planetary system. Considering this classification, one might expect that the corresponding planets would have a permanently frozen structure. However, this isn't true. In fact, the corresponding compounds are in the form of supercritical liquids, meaning they are in an unusual state of accumulation that combines the properties of gases and liquids. Although the orbit of the slightly blue, glowing ice giant was already suspected at the beginning of the 17th century, It wasn't until 1846 that the existence of our cosmic neighbor was confirmed by mathematical computations and observations. Incidentally, the heavenly body owes its name to the ancient Romans. In Roman folklore, Neptune was regarded as the king of the oceans, which seems quite fitting considering the planet's somewhat blue hue, which indeed resembles water. However, as you might have guessed, Neptune's surface hue isn't due to a cosmic water supply but to a lot of methane. The distance between the ice giant and the Sun normally brings some direct accompanying effects. It's nearly 3 billion miles from our host star. To completely circle the Sun once, Neptune needs a period of almost 165 years. At the same time, the days on the ice giant are significantly shorter than on our home planet because of its unpredictable nature. The massive heavenly body needs only 16 hours to rotate once around its own axis. Since there is a tremendous distance between Neptune and the Sun, the power of solar radiation on the planet is also relatively weak. Consequently, the ice giant is characterized by chilly, freezing temperatures. The maximum temperature in the upper layers of the planet amounts to only -330 degrees Fahrenheit. Although the planet is made, as mentioned, primarily of volatile chemical compounds, the assumption is clear that the ice giant has a solid core of an estimated size comparable to our Earth. Temperatures in the world's core would be as high as 12,600 degrees Fahrenheit. Interestingly, Neptune doesn't travel through space alone. As we know today, the planet is accompanied by at least 14 natural satellites, with a central diameter of more than 1,500 miles. Triton is the largest of all known Neptune satellites. Neptune in all its brilliance. If we investigate the overall perspective on the planet, we are really made aware of the natural beauty intrinsic to our isolated cosmic neighbor. Despite the planet's trademark blue tinge, the huge cloud developments immediately catch our eye. Unlike their earthly counterparts, however, these natural structures have an entirely different chemical composition. For instance, scientists believe that Neptune's clouds consist primarily of methane gas. During its journey into the domains of Neptune, Voyager 2 succeeded in capturing not just the planet but also its fine ring system on camera. In contrast to the many rings around Saturn, the rings of the ice giant are much more practical. The individual cosmic rings are sometimes clearly dim. This is due to the fact that Neptune's rings, like those of Jupiter and Uranus, contain a very high proportion of tiny dust particles. Scientists suspect that the dust bodies were kicked up by asteroids striking the planet's moon. Neptune clouds in detail. This intriguing close-up perspective of Neptune's clouds shows that the natural structures in the planet's highest layers form vertical reliefs. Those parts of the clouds that face the Sun are much brighter than the parts of the cloud cover that are not directly exposed to sunlight. The clouds we find in this picture are 30 to 95 miles wide and stretch over a length of thousands of miles. The picture was taken 2 hours before Voyager 2's closest approach on August 25, 1989, when the spacecraft passed the celestial body at a distance of just 3,000 miles. The Great Dark Spot. The Neptune mission was also the first to find a feature on the planet that was subsequently referred to as the Great Dark Spot. Initially, terrestrial scientists thought this massive dark spot was a huge cloud. However, later studies suggested that the structure was actually an opening in the cloud cover, at its center. It was a hurricane system, about the combined size of Asia and Europe. The Great Dark Spot probably moved counterclockwise and took 18.3 hours to complete a full rotation around the ice giant. When the Hubble Space Telescope took another look at the massive storm in 1994, scientists were shocked. The Great Dark Spot had vanished. To this day, researchers do not understand what processes led the storm system to disappear. One hypothesis suggests that the storm succumbed to the heat of the planet's core. The idea that the Great Dark Spot simply dissolved or was hidden by other parts of the atmosphere is also discussed in scientific circles. Little Dark Spot and Bike. The Great Dark Spot wasn't the only storm that raged on the ice giant. Bike, which we recognize in the image as a central white cloud, had already been detected 2 months before Voyager 2 arrived in Neptune's domain. Bike was much faster than the larger dark spot. The smaller cosmic storm took only 16 hours to complete a full rotation around the ice giant. The small dark spot was no less intense. It showed up during the arrival of Voyager 2 as a prominently dark structure. As the spacecraft drew nearer to Neptune, a bright center crystallized. Proteus. On its journey to Neptune, Voyager 2 captured not just pictures of the ice giant but also several pictures of its constant companions. Among the most surprising of all known Neptune moons is Proteus. Unlike most other satellites in our solar system, this small heavenly body does not have a round shape. In fact, Leading up to the Voyager 2 mission, humanity remained unaware of the existence of this unconventional satellite. Despite being the second largest known moon of Neptune, after Triton, Proteus is far from spherical. As the spacecraft flew past the ice giant and its moons on August 25, 1989, the first detailed pictures of Neptune's largest known satellite were taken. As we can clearly see in these pictures, the surface of the celestial body is decorated with innumerable deficiencies. At the same time, the outer surface of the moon has a few impact craters. This led scientists to realize that the moon is still geographically active. The older impact craters on the satellite surface were erased from the cosmic scene by land and environmental processes. No less fascinating was the discovery that articulated volcanic activity impacts the celestial body. Numerous active springs must have been visible, spewing a mixture of dust particles and liquid nitrogen into the environment. The corresponding springs can reach heights of up to 5 miles, after which the mixture falls back down.